Hey guys, welcome back. So in this example, you have a program where your array is sorted and rotated. So you need to find out the index at which your array got rotated. So in general, when your array is sorted array, so basically you know how the sorted array will be. It will be 1, comma 2, comma 3, comma 4, comma 5, right? In general, the sorted array. But when you look at here, your array is 3, 4, 5 and 1, 2, which means your array is rotated cylindrically, right? Which means you know if you try to visualize this guy has got rotated something like this. So after 1, 2 it got twisted. So when it got twisted, it became 3, 4, 5. So basically it's rotated. So if you look at this array in the example given we have, it looks like there is a point called 5 at which your array got rotated. If you look at this diagram, right, this is the point where you know you have twisted your array, right? So you need to find out this index. Like they will ask you to find out the index at which your array got rotated basically, right? So index number is the 5 where your array got rotated. So how do you find out? So here I'll be using that the binary search concept to optimize the output performance, right? So if you have not watched the binary search program, first watch the binary search program which I have explained in my previous video, then you watch this video. Now let's try to understand this diagram first, then we'll start with the coding part. So basically let me take some big example, okay, where we will try to understand how actually this works. So let's say I will take one big array. I will take array like 5, 6, 7, 8, 9, 10, 1, 2 and 3, right? So if you look at now this array, this is the point at which your array got rotated, right? This array actually, if you look at this, also is you know rotated something like this, right? It got rotated. That is the reason it looks like this, right? So this is the point at which got rotated. Now if you notice here, what happened after 10, your next element, okay? So there are two conditions here to find out. So at index number 0, 1, 2, 3, 4, 5, 6, at index number 6, your index number 7, right, is less. That is one conditions. So you can see that at index 6, right, there is one conditions where at index 6, the next data at index 7, right, so this is index, let's say this is n, this is n plus 1, right? So this is one conditions could be one conditions. The other conditions is, let's say if you are on this, assume that you are on this 1, right? You, let's say your middle is 1. In some cases you are at the 1, so there could be one conditions where your middle is going to be lower than the previous one, right? So the middle data is 1 is lower than 10, right? So better here also I'll write 10 greater than 1. So basically here this is, let's say, n, and this is n minus 1. This is two conditions, right? This is the two conditions at which we can find out this is the point at which your array is rotated. You are understood this concept. The one concept is you can find out by coming to this point. You come to this point and you will find out your next data is the lower one, right? That is one way of doing that. The second way of doing that is, you are here, you are at point number 1, okay, and you, let's say this is the middle, and if the middle is the lesser than the previous one, right, if the middle is the lesser than the previous one, that is also the point at which your data got rotated. You understood, right? There could be two things. Either the conditions number 1, either your 10 is going to be the more than 1, like your previous data is going to more than the next data, right? That is conditions number 1. The previous is going to be the next data, case number 1. The case number 2 is where your next data, right, let's say the next data, let's say the 1 which is going to be lesser than 10. This is also the conditions number 2. This is the conditions. So there are 2 conditions to find out whether the array is rotated or not. Let's try to see that how this will work, right? So if you'll go with the logic, guys, this is our lower index, this is our higher index, right? So we'll use the binary search concept. So we'll find the middle. So what is the middle here? So when we'll find the middle is equal to left plus r by 2, which is nothing but 0 plus 1 2 3 4 5 6 7 8 9, right? So add index start from 0, so it is going to be the 9 minus 1, which is nothing but 8 by 2 is equal to 4, right? We have divided the array. When we will divide the array, what we will do, we'll split the array. So let's design another array which is going to be 5 6 7 8 9 10 1 2 and 3, right? You got it? Now this is your L, this is your R, and where is the M now? M is the 4, 0 1 2 3 4. So this is the M, right? So you have divided the array. Now go and check the case number 1. When you will go and check the case number 1 with the case number 1 which we have here, right? If we'll go with the example, it says that if the array of middle is greater than array of middle plus 1. So if we'll go to the first conditions, the first iterations, which is nothing but your first iterations. So in the first iterations, if I'll go and if I'll write is 9 greater than 10, right? This is not, right? This did not get fulfilled, right? These conditions did not get fulfilled. So cross mark, right? Now this is first iterations. Now the second conditions, if the middle one, which is nothing but 9, is the 9 lesser than m minus 1 8, this is also not, right? So what we conclude here, what we can conclude here is at least your middle is not greater than the next element, and your middle is not lesser than the previous element, right? Which means one thing is for sure, your report, you don't have this side, at least this is clear, you don't have output this side. So that part is gone now. Okay, that part is gone. Why I'm saying that we don't have output this side? Because our array is the sorted array, and middle is clearly saying that the previous element is the lesser one. The previous element is the lesser one, which means your array is still ascending. Okay, your array is still ascending, your array is not descending. Your array did not descend, it's still ascending because the previous one is the lesser one. So you don't have output this side. So we need to focus now this side, right? We have to focus now this side for sure. To get the output, we have to focus this side. So somewhere our output will be here, right? But we don't know. Now when our output will be here, again to optimize this, right, should we divide this side also? Yes, we should, right? We should divide this side. So to divide this side, okay, now look at the conditions what I have written here. So actually now we have to divide that. So we have to find middle in this, right? So to find the middle in this, now your lower index should come this side, right? Your lower index come this side because there is no point of working this side. So to bring the lower this side, that's what I have written. If there are two conditions, guys, here. If you focus here, there is first conditions. If array of low which is nothing but array of 0 for here. If 5 greater than array of middle, which is nothing but 9, yes, no, this is not the conditions, right? So this conditions is ruled out. Generally it will happen sometimes, right? Because your middle, let's say you are here 1, right? You are here 1 and here you have a 5, which means you have result this side. You don't have result that side, the opposite side. So in this case, whatever r you have, it should shift before that, because you don't have to work this side, right? You don't have to work this side. You have to work this side. But here this is the case where array of low is not, then we will come to the else part. In else, low is equal to middle plus 1. The reason being is we have to bring low this side, right? Here our low should come. So earlier it was pointing to 9. Our low should come and should point here, right? Why it should point here, right? The reason being is why we should point here is like till here, till this middle element we have verified the previous also, next also. So there is no point of working actually till here. This is ruled out. Okay, so now we should work only after that, because this element was not verified. This element was not verified till here, was already verified. So that is the reason when we shift the L, the lower index, we shift middle plus 1, because work on this side now. Now find the middle here. When you find the middle here, what we will get? What is the low now? Low is the 0, 1, 2, 3, 4, 5. So 5 plus what is the high? Is equal to 8, 9 minus 1, n minus 1 by 2, which is nothing but, if you will do this calculations, right, which will come 6.5, which is nothing but 6. So your middle is going to be where? Your middle is going to be somewhere here. So 0, 1, 2, 3, 4, 5, 6. So this is your middle. Okay, now this is your middle. When this is the middle, guys, now try to understand. When this guy is the middle, now again iteration number 2. Okay, iteration number 2. What is the output here after iteration number 2? So if the case 1, if middle is greater than middle plus 1, 2, if this is the case, right? No, this is not fulfilled. Case number 2, if middle, if 1 is lesser than middle minus 1, which is nothing but 10. Yes, correct, right? Now you can understand the usefulness of this logic, right? Because your middle is here now. So you understood now. If this is the case, which means this is the point at which your array got rotated. Now whatever I have explained earlier, you understood. So this is the point. Okay, now this is the point at which your array got rotated. So what you have to return here? M minus 1, because this is your M, this 1 is the M. So you have to return here, return M minus 1, and this is the output, right? So this is the index at index 10 at which your array got rotated. Now the same thing I have converted to the code also. So just if you know this 4 line, it is enough for you to solve the problem. Okay, if you just know the 4 line. Now let's come to the program. Now we will try to understand the program. So the same example, guys, I have given here also. You can try to understand, try to practice, but let's focus on the program here. Now look at this while conditions. Okay, so you can see that the same thing, array low and high, and then there is a while condition. So why while conditions? Because you have to run a loop, right? Since there I was explaining it, I didn't write the loop, but here you have to run the loop because you are working on the array, right? So you need to run the loop. And now there should be, when you run the loop, there should be some conditions which will terminate your program. So here high is equal to low. Why I'm saying that high is equal to low, guys? Okay, if you try to focus, let's say you have array like this, you have a big array. Assume that you have this array where you have a L and you have a R. Somewhere here you have a middle. Okay, so tell me one thing. is there any chance where your high is R is going to be low? No, there will be never a chance, because let's say this is one division. Okay, now you did one more division, so you made one more M1 here. When you made one more M1 here, you know what happens? Your R1 will come here. Okay, this is another division. See, here also the R is greater than L. Now you did one more division, right? You did one more division where your M2 is here, like you have divided in between these two, right? And when you divided M2 is here, then your this guy will become L1. You can see that. So when you have to work this side, right, your L1, it will from here, it will come here after M, right, this side, and R will not change. But when you have to work on this side, then your L1 will be same. Your R, whatever R you have to come before middle, because you have to already checked till middle. So your R will be here, R1 will be here, and M1 will be here. So one thing we can understood here is there is a no chance where your high index is going to be the low index in any of the segment here, right? You can see that low is always lower than high. Okay, so this is your terminations point, where high should be always greater than low, right? If this is the case, which means return -1, just for safety measure. Now there could be the chance that where highs can be low, there is a possibility. Okay, then return the low. This is just two precautionary conditions. Now this is the way you find the middle, low plus high by 2, which I have explained you, whereas high is equal to n-1, because when you are counting from 1, then you have to do n-1, or it's up to you how do you count, right? So this will give you the middle. Now guys, focus on this 2, which I have explained you, the case number 1. So the case number 1, why I am writing that middle should be always less than high. Okay, precautionary measure conditions we have to write, middle should be always less than high. Look at here the program. When I divided this part number 1, part number 2, in any cases the middle was lesser than the high one. Okay, in all the cases, actually, even in this case your middle was actually less than high, right? But the middle was always greater than lower one. Here also the middle was always greater than the lower one. You understood? So the same concept is here. Middle should be always less than the high, and if the area of middle greater than area of middle plus 1, right? Again, if I have to quote, I can quote the same example, whatever I told you there. So I can write here 5, 6, 7, 8, 9, 10, 1, 2 and 3, right? So if the area of middle is greater than area of middle plus 1, okay, which is which case? Which is this case. If this case is there, please return middle. I have explained already. Now if this case is satisfied, now middle will be always greater than low. I have explained you. And if the area of middle, which is nothing but, there was one case, right? I have explained you just now, where 1, we were on the 1. When we were on the 1 will be lesser than 10, right? That conditions is also there. So that is the reason, if you look at area of middle is lesser than area of middle minus 1, if this is the case, then return what? Middle minus 1. Okay, because you are here, so technically you are here. When you are here, this is your middle, right? So basically here your middle is less than middle minus 1. If this is the case, then return middle minus 1. But if you are on the 10, right, if you are on the 10, so if you are here basically, then actually your middle is greater than middle plus 1. In that case, return middle. Okay, because the point at which you are getting, in this case, this is the point at which you are going down. Okay, but when you are on the 1, this is the point after which you are getting down. That's the difference. So you have to return 10 here. In this case also you have to return, in the both the cases you have to return 10 only. So in the second case you have to return m minus 1, the previous one, whereas in the first case you have to return the point at which you are. Okay, now these conditions also we have seen that this will eliminate like which side we want to work. So this is the let's say if there is a case where your array of low is greater than or equal to array of middle. So assume that there is one, let me write one. So how should I write that? Let's say you write 5, you write 3, you write 2, and you write 1, and then you write 0, something like that. So assume that, just for understanding, I have taken this example. Okay, this is your low, this is your high. Okay, and when you do L plus 0 plus 1 2 3 4 5, which 4 by 2, which is nothing but 2, 0 1 2, which is nothing but here. Your M is here, guys. Okay, when your M is here, right, when your M is here, technically you are here. When you are here, so tell me one thing, is your M is greater than M plus 1? No, right? Correct? No, right? But let's say you are here, when you are on the 1, right, when you are on the 1, in this case, if M, which is nothing but 1 now, okay, if this is lesser than M minus 1, which is nothing but 2, so 1 lesser than 2, yes, so this is the point at which it is rotated. Okay, this is the point. Here you got the report, but let's say you did not have got the report here. Okay, you did not have got the report here, then there could be one conditions where you are saying that if array of low is greater than array of middle. Okay, so if this is the case where the low itself, like this is the middle and low itself is bigger, right, in that case what you have to do, your output will lie somewhere before middle, your output will lie somewhere here, correct? But luckily, when whatever example we have took, in this example what happened, our middle after this case 1 and 2, okay, after both the cases are actually middle was greater than the lower one. Okay, when that is the case, then we have to shift the lower here after middle, which I have explained in the diagram also when I was talking here. I have explained you clearly. If you have any doubt, please watch this video again and again to make sure that you don't have doubt. If that is the case, then increase low by middle plus 1, right, and you will get the output. So I'm hoping that this program is clear for you and you will be able to write this program in your Eclipse and you will be able to do the practice. Thank you guys. Thank you for watching this.